Now we are asked to explain the intermediate value theorem. Well, the textbook definition says let x sub 1 and y sub 1 and x sub 2, y sub 2 with y sub 1 not equal to y sub 2 and x sub 1 less than x sub 2 be 2 points on the graph of a continuous function f. Then on the interval, x sub 1 is less than or equal to x, which is less than or equal to x sub 2. F assumes every value between y sub 1 and y sub 2 at least once, blah, 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 right? Okay, so maybe I added that blah, blah, blah part because, oh my goodness, that just doesn't make any sense. Let's set that off to the side there. So, really, this theorem is pretty simple. Let's take this adorable choo-choo train, and let's say that this is our x-axis, and we have a point here and here. Well, let's say at point A that this train is moving at, I don't know, let's say 40 miles per hour. We can do that. So 40 miles per hour. But when this little train gets to point B, then let's say that it must be going, a good 80 miles per hour. So the intermediate value theorem is simply stating that between 40 and 80 miles per hour, between point A and point B, the train jumps. No, it doesn't jump. The train must, at some point between A and B, go, 50. At some point, it must go 60 and 70 to get to 80 miles per hour. So, this theorem is simply stating that in order for this train to move from point A to B, to move from 40 miles per hour to 80 miles per hour, it must hit every single point on the run between A and B. So, that's it. It's that simple. The intermediate value theorem basically states that between the 2 points, we could call it x, x sub 1, x sub 2, right? And then, you can see that every point must be hit. It assumes that every value between here and here must be hit at some point. Yeah, so the intermediate value theorem is just basically simple logic.